Hello, good morning, all. Thank you for joining this webinar on time. So, my name is Srishal Biradar. I'm a technical manager for simulation product, joined from Bangalore. This webinar was supposed to, presented by Mr. Agastya, my colleague from Hyderabad. So, due to some emergency, he is not available. Hence, I'm taking this webinar today. So meanwhile, I request I request you to little wait for 30 seconds or so. So I'll just wait for a couple more attendees to join, and then we will take it forward. Thank you once again for being on time. Okay, let's get started without further delay for this webinar. The webinar today is, the topic is powering aerospace and defense innovation with the help of Powerhouse 3D Experience and its allied SIMULIA products on top of it. So let's get started on the introduction. So before me starting the section, I have a few polls for you to answer the things. And before that, if you are unable to see my screen, if you are unable to hear my voice, please do type it in Q&A section. So we will, a few of my colleagues have already joined here. They will basically, correct if any technical glitches are there. I hope my voice and screen is clear and visible. So before that, I'm just launching few polls. I request each one of you to participate in this. Okay, let's launch the poll. Okay, let's get started with the presentation. Thank you for your responses to the questions which I hosted. So, see, why do we have to talk about virtual testing? Whether it is 3D experience or the legacy simulation, doesn't matter. What is the meaning of using virtual testing? So the virtual testing or simulation basically helps to increase your innovation and basically helps in terms of increasing the performance of the product that we design, helps to choose the optimal design before it goes for the final testing. And obviously it basically gives you to explore on the design space. If let's say, for example, if you have multiple ideas in your mind, it basically helps you to explore all those things and choose the best design first time and every time. That is the meaning of virtual testing or simulation solution. And also it in a similar a point of interest, it basically helps in terms of increasing the total cost that involved in the product design and time to market. It basically helps you accelerate your product faster to the market, and then it basically reduce the failure rates if you are facing, and obviously the risk of ineffective product being produced and sold in the market will basically decrease. That is the a point of doing virtual testing or simulation. So today, with respect to our simulation solutions that we are offering from Dassault System, so Dassault System is having a dedicated simulation team wherein it builds the solution across all the physics, whether it is industrial equipment, aerospace defense, or if it is automotive industry, or if it is into high-tech electronic devices, medical devices, or the aerospace and defense, which we are going to talk today. So it has got various solutions across different platforms to address all these challenges with respect to the virtual testing and so on. So, and let's first understand the myths and reality about the simulation. So when you talk about simulation, earlier there used to be a fear of investing on the simulation because we always felt simulation is hard to use and complex equations to be solved. These are all the myths that I'm talking with respect to simulation, and we felt very much expensive to invest on costly resources on the both on the manpower, on the infrastructure. And we also think that it has got only limited computer power, and it takes long design iterations and so on. But today, if you see, simulation is being democratized. That is the reality of simulation with the 3D experience that we're providing. It has got powerful solvers from solvers like Abacus and CST Studio Suite, and yet it is easy to use and handle by the designers, analysts, and the specialist. And it has the biggest advantage, 3D CAD integration. That means to say there is no need for you to learn a new graphic user interface, or there is no need for you to switch between the windows for doing the modeling and simulation. That is how a simulation is very much powerful today with the help of 3D experience platform. And quick design change. Since this is a 3D CAD integration tool, any changes that we make to our design at any point of time, it will be quickly updated in our simulation study. It is fast to run the simulation with the cloud resources, cost effective because it has, it can be scaled across different user levels. And when it comes to post processing, the good result visualization with the help of, cloud applications, and with the help of cloud computing, there is no need for you to worry about the limited computer power. You can expand your running simulation using up to 144 core or up to 256 core. There is no limit. That is how Dassault system, with the help of 3D experience on the 3D experience, basically democratize simulation today. This is how simulation taking the future things with respect to part of complete product design process. So what drives product development? When I say whether it's aerospace defense or any product for that matter, the product development, the first comes is the performance. How does it perform, keeping its key performance indicators? How strong it is when I design any product, how stronger, how it will sustain in the market, and various with respect to performance. Again, what kind of material, what is the innovation behind it, how lighter is my design, what is the quality aspect of it, how safe it is to use in different applications, and what is the risk of this product release to the market, and price to cost. It is always very much important. And the eco-friendly, that is sustainability, which I was talking about, is also very much important. And how soon we release this product to the market, time to market, manufacturability of it, whether it is additive manufacturing, injection molding, whatsoever. I mean, what kind of energy that is being consumed, heating, how does it perform under different weather conditions like heating and cooling, what kind of regulations it has to undergo before releasing into the market, what does it undergo, any kind of vibrations, how is it connected with the help of smart devices, and if so, how the efficiency of those smart devices. All these things basically drives the product development, right? So moving forward, keeping all these aspects in mind, today I am going to concentrate on the performance of a drone here, which we basically helps to do the optimization using a Powerhouse 3D Experience SIMULIA applications. So when I say drone for aerospace and defense application, so the major challenges I may incur, like what if it doesn't perform, and what if it being suddenly dropped, and how it is going to create an impact onto the other sub assemblies which are present in the drones. And what if the thermal parameters, because it is having a lot of electronic devices, what if it is not having a proper cooling methodologies? And the third challenge is the communication between the operator to this unmanned aerial vehicle, how effectively the communication is being transferred. So if these, the structural strength, thermal performance, and the connectivity are the major challenges for designing any kind of unmanned aerial vehicle or the drones that we're going to talk about. So how do we address these challenges? By making use of a 3D experience SIMULIA application. Let me first take an example of structural analysis, the strength analysis. The factors to be considered for the drone design is the structural strength analysis for various structural loads, for example, static load, dynamic loads, linear loads, non-linear loads, and the drop impact during a certain unintentional event. And since it is having a lot of motors, how does it perform under the vibrational cases? What is the durability of it? What kind of materials should we use? And then comes the aerodynamics, that is basically the aerodynamic performance on the flight characteristics, and the regulation test, the electromagnetic compliance. These are all the major challenges so we can address by making use of 3D experience simulation solutions. So let's see one by one. Before that, how 3D experience works is different compared to any kind of standalone simulation solutions. So the first, which I was talking about, the integration, I mean the simulation driven design. That means whatever the simulation we are going to do, whether it is the structural simulation, thermal simulation, or the electromagnetic simulation, all the time we are always integrated with the 3D modeling. That means any changes that we make to SolidWorks will be directly updated in all these respective simulation studies. That is the meaning of integration and designer centric. These tools are very much easy to use. Any designer who is working on SolidWorks will be able to learn these things very fast, and he will be able to work efficiently. And 3D experience has a comprehensive simulation physics. All the advanced capabilities can be solved even with multiphysics, like coupled physics domains, like fluid structure interaction or the thermal structural interaction. All these capabilities are there. So the another biggest advantage of 3D experience simulation is the cloud solving functionalities. So you need not have to depend on the local resources. You can directly run the analysis by making use of the cloud resources, which basically helps to reduce the infrastructure on the investment of IT. So scalable across all the user levels, like structural user, from basic to designer to analyst, and from there to expert. It can be scaled across all the user levels. That is the biggest advantage we are going to get. And it is the collaboration is the key here, because all this simulation are basically CAD and PLM integrated. So the version control, revision control with respect to product lifecycle management, everything is integrated with CAD and all these allied simulation products. So with that, let me take you through let's first take the structural capabilities here, the strength and durability if I have to do. So on the 3D experience, the solutions that we have is, the name is durability and mechanics engineer role on the platform. So you need not have to worry about the name here, but it basically enables the comprehensive structural simulation covering static, implicit and explicit, dynamic, fatigue functionalities, structural integrity of all kind of products can be calculated here. The key things for this particular durability and mechanics engineer role is basically the industry leading Abacus solver. It has FE-safe solver for durability analysis for both low cycle and high cycle fatigue, and automatic modeling and meshing, and comprehensive material modeling capabilities are a part of this particular role. So what can be done by making use of this capability of durability and mechanics engineer role? It basically checks the stresses and deformation under the static conditions to basically avoid the failure before even producing a single prototype. And you can basically decrease the over dimensioning. That means you need not have to over design it. It basically helps you optimize your design. Mechanical resistance on the parts and assemblies basically calculates the factor of safety, and basically helps you choose the best design and enhance the productivity of the drones. So here are the few results on the structural strength analysis that has been done on the drone frame. On the left side, you will be able to see the stress plots done from the 3D experience structural solver. That is basically the Abacus. You can just see how much the maximum stress it is undergoing, the 25 megapascal. On the right side, you will be able to see the deformation plot, which is seeing a 0.18 mm under the static loading conditions. So similarly, if I go forward, the next challenge which comes, as I told in the beginning, the vibrations, right? So before doing any kind of a vibration, first we need to understand the natural frequency of the drones. That is basically the model analysis. So 3D experience simulation solution has a capability for you to do the free vibration, forced vibration for any kind of application, especially for aerospace and defense application. So all these vibration analysis with respect to military standards and so many other standards, it is very much important. Here, it provides the capability for you to calculate the eigenvalues. So here you can just see I have extracted the first 30 modes ranging from 171 hertz to 897 hertz, and you will be able to see the different mode shapes on the right hand side. The mode shape at 342 hertz is being shown here, and mode shape at 852 hertz is also being shown here. So this is how the visualization is available inside SolidWorks, inside the 3D experience simulation applications. So now what about, now we've seen the free vibration, but what about the forced vibration? It might experience harmonic vibration, it might experience random vibrations with respect to military standard, shock vibrations, and so on. So here is an example of a harmonic vibration wherein, so I am exciting this particular structure from 0 hertz to 2000 hertz, and you will be able to see a different peaks here. Let me take a pointer here, so you can able to see a different peaks at different frequencies. That means, so if my excited frequency is matching with the natural frequency of the structure, there is a sudden raise in the value of stresses, deformation, acceleration, and so on. So if I have to keep our structure safe under the influence of these kind of vibrations, we have to keep these peaks as minimum as possible. That is how this SIMULIA application gives an indication to the user to make any changes, design modification, and optimization before even producing a single prototype while they build the 3D model. So moving forward on the drop impact, so we have a explicit solver with the help of Abacus here. So the Abacus has both implicit and explicit solver, especially for high-speed events like crash test, drop test, the package drop test, or so on. So we have a exclusive Abacus explicit solver for doing this kind of impact and drop simulation. So this is an example of the drop test that is being done on the particular drone. And moving forward, those are all basically on the static analysis, vibration, impact, and similarly, a lot of things can be done. But what about the durability? So we have a industry-leading EFI-Safe as a durability solver. So in this, to explain the capabilities of that, I have just taken the quarter model of this particular drone by making use of the EFI-Safe solver, and the static load which I'm going to apply onto this structure is 50 Newton. And for a reference, I have taken a material that is basically the 6061 alloy for the fatigue data. So once we do the fatigue, so here, when I say EFI-Safe, it supports both high cycle and low cycle fatigue analysis, but it considers both strain life, curve and stress life curve to basically, determine the life of this frame in terms of basic repeats. But the minimum repeats option is 3.95. That means you have to basically, if you have to really get the value of this, you just have to 10 raised to 4 is the total life of this. And similarly, after that particular life, what is the damage that got initiated can be calculated on the durability solver. So it is not just limited to metals. You can do the durability to various other materials also, like you can do the durability for rubber material with the EFI-Safe rubber solver. You can do the durability for composite materials with the different theories of failure. So there is no limitations. And I mean that is the key advantage of using both Abacus and EFI-Safe solver. So I was talking about the composite materials, right? So nowadays, I mean, not nowadays, basically all the aerospace and defense application are basically a lot of research is being done to use the composite material because of its light I mean, a strength to weight ratio is very high compared to the conventional, materials. So, I mean, how do we model this? The analysis of composite material is not as isotropic as other, materials, right? So, I mean, here Abacus basically gives you a flexibility in terms of defining the layer-wise definition. Here, I have taken an example of carbon fiber, which is modeled using the engineering constraints. That means the Young's modulus in all three different directions, like in x direction, y direction, and z direction, it will be having the different values, and similarly the Poisson's ratio and the bulk modulus. So it gives you a flexibility to model all these information with respect to layer wise. We can give those properties, and here, if you can closely observe on the left hand side, there is a layup modeling for the composite materials, which is very much important when you are analyzing any composite material. So I have not taken very complicated model here to explain the capabilities. So I just taken one this drone quarter model, and which is basically modeled using three plies to just show you how easily we can basically define these functions. So here, the first layer, if I made up of carbon fiber, and all these three layers are made up of carbon layer with the element thickness of 0.5 mm and a different coordinate system, and the orientation is very much important. The first layer is having 0-degree orientation, 30-degree variant, and the -30. It's like that. The composite, how exactly we do it in the practical condition. In a similar fashion, we can basically define here to simulate using as realistic conditions as possible. So once we do that particular analysis, you have excellent post processing for the composite material also, to basically visualize the stresses, deformation, factor of safety, and so many other variations across all the layers. Like here I have plotted for the stresses for the layer 1, layer 3, and similarly for n number of layers. Like if you've taken any big aircraft wing, it will be having multiple layers, right? Even layers extending to 30 layers, 40 layers, 50 layers. So there is no limitation to define the layers here inside the Abacus. That is the point which I'm trying to make. So those were the capabilities with respect to structural performance calculation, and the next is with respect to aerodynamic and calculating the flight characteristics. So here again, in the same graphic user interface of 3DEXPERIENCE simulation, so we have got excellent a fluid dynamics solver with the help of again the Abacus. They have built a very excellent solver for you to do both internal and external simulation analysis. And in this particular aerodynamic analysis, which basically enables the designers, engineers to gain insight about flow and thermal performance to improve the product designs. So here again, the key benefits is going to be the remain same. They are design centric. There's automatic meshing, especially the meshing is very much easy to generate. Automatic generation of fluid volume, body fitted meshing, boundary layer, everything happens in a very easier and automatic manner. And as far as turbulence models are concerned, especially when we are doing the aerodynamic analysis, the important turbulence models on top of realizable K epsilon model, like the K omega model, SST spalatal MRS. So those things are always available with the help of this turbulence models, and it also has a comprehensive flow and thermal physics can be accurately predicted. So here to take an example of the aerodynamic analysis, here you can just see how can we understand the aerodynamic forces like lift force and drag force with respect to different angle of attack. So I have considered an angle of attack from 0 degree to 5 degree here. The set velocity is 25 meter per second. The wind velocity here considered. The pressure around the drone is set to be atmospheric for simulating the virtual wind tunnel test. So here, when we do the parametric optimization or the parametric study or the design of experiments, so the first one basically gives you an the distribution of pressure on the complete surface of the drone or the unmanned aerial vehicle, which I'm talking about, the pressure plot of angle of attack at zero, angle of attack and the respective streamlines. So what I'm trying to talk here on the result visualization, when we do any aerodynamic analysis, like the different parameters, the pressure distribution, velocity distribution, if any thermal things are there, the temperature distribution, or the different turbulence parameters, air, the lift force, drag force, anything with respect to aerodynamic characteristics can be calculated with the help of this excellent, post-processing parameters. Moving forward, so I'm just comparing here the two different angle of attack things. Like on the left side, you can just see the 5-degree angle of attack. What is the pressure distribution and how it is changing with respect to 0 degree to 5 degree, and similarly the net force and the net axial force that is being acted on the 0 degree angle of attack or 5 degree attack. So all these important parameters, how do we do it in our experimental a case study by making use of wind tunnel. So this FMK or the fluid dynamics solver on the 3DEXPERIENCE platform basically helps to capture as realistic cases as possible. That is how the fluid dynamics solver is unique in nature to basically do the aerodynamic simulation of this drones. So here is a quick post-processing related things. Here I have on the first one, you can just see the lift coefficient versus angle of attack. As the angle of attack is increasing, how it is influencing basically the lift coefficient, drag coefficient, or the lift by drag. These are all the important flight characteristics with respect to any aerodynamic application with respect to different angle of attack. So those things can be calculated here. That is the key. That's what I was trying to tell. The turbulence models, the industry standards things, they basically helps to capture as realistic things as possible. Here, the cruise aerodynamic characteristics on the top end side, you can see the wind tunnel test. They have done using the experimental wind tunnel test, and on the left side on the graph, you will be able to see the wind tunnel data with respect to 3DEXPERIENCE CFD, how closely it is basically matching. That is how these tools have been validated before releasing, and that's what is I'm sorry. So that is what different angle of attack with respect to different drag coefficient, lift coefficient, how accurately. So you'll be able to match with respect to experimental test data. So moving forward, so we have different fluid solvers with us. One is on the SolidWorks platform. That is the name is SolidWorks Flow Simulation. The Aerospace Defense applications, if you see calculation of lift force, drag force, L by D ratio, and the performance of any drones with respect to rotating domain and with respect to different meshing technique, the immersed boundary technique, the automatic adaptive meshing, and different other things with respect to aerospace and defense application by making use of both SolidWorks Flow Simulation and the 3DEXPERIENCE. So SolidWorks Flow, the Flow Simulation is good till the Mach number is 0.3, and anything beyond 0.3, we have a 3DEXPERIENCE SIMULIA, that is from Abacus Solver, with the help of all the advanced turbulence models. Even for doing this kind of analysis, it is very much effective. So that is what I'm trying to make a point here. So that is on the what I call the aerodynamic part of it. So we have started with three major challenges, right? One is on the structural challenge, which we have addressed by making use of the structural Abacus solver. The second challenge was which was respect to aerodynamics, which we have covered by 3DEXPERIENCE CFD application. The third thing is about how the communication for this particular drones when it is being operated it will be having different electronics, right? On the remote, it will be having different electronic device. It will be having different antennas, and on the other controller to communicate, it will be having a transmitter and receiver. The performance of that under the electromagnetics is also very much essential. So on the 3D experience platform, to address this particular challenge, we have come up with one of the industry leading electromagnetics solver. The name of the solver is CST Studio Suite for doing electromagnetic simulation, for doing analysis right from low frequency to high frequency application, especially from applications like motor, applications like transformers, applications like generator, and taking those capabilities forward with respect to all the high frequency applications like RF microwave, and also the antenna performance, also the printed circuit board, the power integrated test, signal integrated test, and then the the regulations, the compliance test with respect to electromagnetic compliance and interferences, the EMI/EMC simulation. It has a capability for doing with respect to all the aerospace and defense application. As I rightly mentioned, it had the name again. So on the structural, it was durability and mechanics engineer role. On the second one, the fluid dynamics engineer role. The third one is electromagnetic engineer role. So if you remember, when I was introducing the key things about 3D experience platform, I was talking about the scalability. So it is scalable across all the user levels. That means it can be used for the structural engineers, the 3D experience platform. It can be used for thermal and aerodynamic engineers, and it can be used for electromagnetics engineers as well. That is how all these physics are being connected in one single platform called as 3D experience platform. So, and again, it is very much easy to use for electrical and electronic applications. So here, if I have to talk about the electromagnetics simulation with respect to aerospace and defense application, so I mean, I just listed few important applications like lightning study. How lightning, and how do we place the respective components to basically study this effect. RF interference checking can be done. EMI/EMC compliance test, which is mandate for your electronic devices on the aerospace, right? So it basically helps you to address all those EMI/EMC challenges. And for the communication, especially for the drone which we are talking about, the antenna is one which a lot of communication happens, and which is the right location to place it, is very much important. So basically the various efficiency parameters can be measured with respect to antenna placement, and it basically helps to choose the the best place for the effective performance, and so on. And here another key advantage of this electromagnetic simulation is it can directly read the 3D model from the SolidWorks, and it also reads your electronics data like ECAD data, or directly from native file formats like ODB++ data, the printed circuit board information with all the layer information, the vias information directly inside the electromagnetics engineer role for you to do any kind of electromagnetic simulations. So here the different performance when if you do the antenna without installing on the final drones, the standalone performance with respect to different S parameters, or with respect to different antenna performances can be seen here. And what is the performance change when it is installed on the real drone, the one case. And again, as I told, if it is placed in different orientations, how effectively it is able to receive the signals to have a efficient operation, and to have a efficient communication between the operator, from the remote and the receiver and transmitter. That kind of important analysis can be done with respect to different materials and different placement of antenna. So here is one of the important output, the E field at different 2.4 gigahertz frequency, how the E field is being varied. And that is what I'm trying to tell here on the electromagnetic simulation, different E fields can be simulated at different frequencies, and you will be able to see whether it is meeting your end goal, or is there any modifications has to be made with respect to antenna design or with respect to its placement. All these important parameters can be studied well in the stage of design stage, even before making a combined conclusion with respect to mechanical or thermal or the aerodynamic engineer. That is how it basically gives you an idea. And on top of that, the radiated emissions with respect to enclosure with the slot and without slot, all these important things. So all the studies, if you have ever come across the real radiated emissions, you will be able to connect how accurately and how beautifully it is basically getting the different contours with respect to different frequencies. You can just see the 0.88 gigahertz, 1.12 gigahertz cavity slot, and only the slot, and with respect to different the parameters. That is how any changes, as I told, at any point of time to the designs, to the enclosures, how it is affecting the end performance on the electromagnetics that can be studied. And this is again on the motors. Let's say for the quadcopter, you are using the motor, and if you're designing it, so how efficiently they are working. Let's say if I give this much of power, what kind of electrical output they are producing, and what kind of mechanical power with respect to different speed, and what kind of electromagnetic field it is undergoing. All the important parameters with respect to even the low frequency is possible within the electromagnetic solver on the 3DEXPERIENCE platform. So that is about the complete technical aspects on the structural strength, aerodynamic flight characteristics, and the electromagnetic compliance. But another important thing about 3DEXPERIENCE is basically the cloud computing, which I briefed in the beginning. So what is this basically? The 3DEXPERIENCE basically connects your simulation data directly to the cloud. If you don't have enough RAM for large models, and if analysis is taking too long for the complex runs, so if you have to run a multiple analysis at the same time, 3DEXPERIENCE has the answer for all these questions, wherein you can directly take your data to the cloud for running simulation. It doesn't matter. We have a unified token system wherein these tokens can be used to run structural simulation, durability simulation, thermal simulation, and the electromagnetic simulation. That is the power of 3DEXPERIENCE unified licensing model. So you must be having certain challenges, like when you go for the on-premises HPC, we know only the known cost, that is hardware is very expensive, but it also has a lot of hidden cost associated with it. We always overlook on that. Basically, if you see, the known cost is basically the tip of iceberg but whereas the hidden cost, like outages, UPS, power cooling, maintenance, security, so many other things, if you basically invest on the physical hardware and the life of the physical hardware, it will, if you use it for 3 years down the line, people call it as outdated. You have to undergo the complete replacement of it. It is way expensive. That is when people choose this particular cloud, wherein you can directly submit your data on demand cloud, which is available at any point of time. If you want to run today the analysis using 36 cores, and if you want to run using 48 cores, 72 cores, 144 cores, 256 cores, there is no need for you to invest on the hardware. All you need to do is you just have to buy a respective tokens or credits, and you can just submit this analysis to get it done by making use of the cloud resources. And the beauty of this computing on cloud is they are available on demand 24/7, high performance computing, cloud instances with largest generation CPUs, up to 144 true cores per analysis, and it can be true 256 also for different analysis. Distributed computing with low latency networking, high performance, and scalable storage. So even if you submit the analysis, you need not have to keep your workstation open. So backend, it will be using the cloud resources and it will be running the respective analysis. That is the beauty of the cloud computing and the 3DEXPERIENCE platform. So I'd like to conclude this particular section, this webinar, with few customer references where we are successfully able to make a transaction, and they're successfully using our tools to use our tools in different aspects. Here is an example where the National Aerospace Laboratories, they have basically invested on both Abacus as well as on the CST Studio Suite, and they have presented in one of our biggest regional user meet, which is conducted last year, and they have presented how they used the CST Studio Suite in different application, lightning, high intensity radiated field, and so on. They basically use this particular CST Studio Suite for various applications, and they are one of our largest customers in the CST Studio and Abacus solvers. And similarly, the Range Aero, they are again the Abacus users for this particular drones, and they were able to shorten the development time by 40%, decrease the development cost by 30%, and they were able to cut down prototype things and all for you by using only the Abacus solver. So, and here is one more case study, the Aerial eVTOL Vehicles Private Limited. They were one of our fluid dynamics engineer customers, along with SolidWorks, for calculating the flow performance of their aerial vehicles. And Ikron Aerospace, again, it is a startup company, but they were able to get a lot of benefits from 3DEXPERIENCE, not only on the technical side but also on the commercial part of it, or on the support part or the training part, and they were very much happy to use it for testing and validating the different performance of their aerospace and aerospace applications. Another Axel drone, exactly doing the drones inside the 3DEXPERIENCE simulation. And here, if you just see the challenges, reduce number of prototypes and prototype cost, reduce product. These are all very much similar challenges and solutions. If you see here, the one durability mechanics engineer role was purchased in 2023 under the startup program. And if you see the benefits, since they have an integrated design environment, they were able to cut the design cycles by 30%, and shorten the time to market by 20%, and reduce development cost to 25 to 30%, and slashed manufacturing cost by 50%. So this is the key, basically. Investing on these tools and deploying on these tools very early in the design stage basically helps you realize your return on investment. That is how all these customer success are talking about. So to conclude this, the key takeaways here: simulation as a strategic advantage enables faster innovation, reduce risk, lower cost, and shorter time to market, end-to-end simulation driven design. There is a unified platform, which I was continuously talking throughout my presentation. The unified platform, the integrated CAD design for multiphysics simulation and the PLM collaboration. Comprehensive and virtual validation. It has all the capabilities, the multiphysics, like I said, the structural physics, vibrational and durability, composite, aerodynamics, electromagnetics, you name anything with respect to aerospace defense for or validating the things, we have the solutions. Smarter engineering decisions, early design insights, and you will be able to realize from various customer studies, case studies which I've shown, they are basically the early adopters of the simulation solution. They were able to get a lot of benefits on their new product development process. The key here is early design insight, reduce physical prototypes and improve performance and safety. Scalable and cloud computing. On-demand HPC eliminates IT constraints and accelerate complex simulations. Proven industry impact. Successful drone programs delivering measurable gains in time, cost, and quality. So these are all the key takeaways for today's webinar. So I hope I could able to complete it in a given time. So, and I hope this webinar was useful to all of you. So once again, my apologies, because I mean my colleague was supposed to present this. Unfortunately, he was unable to do it because of some emergency. So nevertheless, I feel I in a nutshell, I could able to I could able to make what I was supposed to deliver in this particular webinar. So now we are open for any questions that you have, and if you have any questions, do not type, or do not hesitate to type in Q&A section here. We are just open for question and answers. So we'll be waiting for your questions. Yeah, I have one question here from the participant, Mr. Prasad. If I read it his name correct, will I get any participation certificate? So I'll get back to this, Mr. Prasad. I'll talk to my marketing colleagues, and I'll get back to you on this. Thank you for asking the question. Any other questions? Kindly show the list of companies at the end. I want to know them. So, Mr. Prasad, we will definitely, share all the list of customers to you, with the help of, a separate email. So I'll basically, send all the, users of simulation from our side. I got your question. We will, share it separately by email. Thank you for asking the question. And if anybody has any other questions, can you please share this document with us? Sure, we can share this. We can share this, separately. Recording, yes, it is available. It is available, and we will put this in our official website, and we will make this available to all the attendees, and even some people, if they miss to attend this, it is available for them as well. And anybody, if they wish to take a detailed demonstration pertaining to their particular products and their particular application, please do write here. So we will take that as a note, and we will reach out to you separately. You can always write that question here. So I request all the participant not to leave this webinar instantly. So once I complete this, say complete, you will be redirected to feedback form. I request and I basically urge you to provide your positive feedback to improve our deliverables in the future. Thank you very much. So if I have no questions, we'll be closing this webinar. So we have some more questions. What is the validation methodology of simulation resulting 3D experience? Mr. Karthik, the validation methodology on the 3D experience, there are three physics, like I mentioned. The structural is basically the abacus solver. For both, in fact, for both structural and fluid is the methodology or the solver. I understand that you are asking the solver. We have the abacus. For the electromagnetics, that is the CST Studio Suite. Another question, as a beginner to use the software, what would be the recommended roadmap you might suggest? That's one of the, this is a good question, Mr. Sai. We have a dedicated, training and simulation team where we basically do the training right from the scratch. The complete hand-holding is a responsibility of for Beacon team. There is we have a proper roadmap with respect to different physics. We will basically do the complete hand-holding from the scratch, until you get used to the software, whether it is structural, thermal, or the electromagnetic physics. We have a proper, training program for the people who will invest on our tool. Another question, can simulation be useful for furniture manufacturing industry? Yes, of course it is useful. I mean, that is the key advantage of abacus. So any kind of material, it has an open interface to model any kind of materials. It is not limited. If you if you give us a separate meeting, or we will be able to come down to your premises and we'll be able to make a detailed demonstration with respect to your application. Okay, we'll share the detailed things to your email ID as well. So recording, recording will automatically come to your email ID. Okay, I hope we are done with questions. There's, how do I join the training program? I mean, how this results are valid. Okay, the question is how the results are validated. See, the solutions, whatever we are talking about, the abacus, the FMK, or electromagnetics, these things are basically those, validated against the test or the experimental results from the third party agency called National Agency for Finite Element Method. So they have done the validation. That is one part of it, and a lot of other case studies which have shown wherein the people who are using our tool, they themselves done the physical testing and then they have validated it, and we validated our own results with because we are the validated resellers. We don't have any physical testing setup with us. We basically validate our results by referring to various journal papers published in the international forum. I hope I answered your question, Mr. Karthik. How can I join the training program? There is no training program for the people who are not using it. So I hope once you purchase the license, and the training is default included in it. Could you provide information on how AI or real time is associated with this software? So I am unable to get your questions. I'm sorry, Mr. Joshi. If you can just please a little bit elaborate, it will be easy for me to get what you are exactly referring. I'm unable to understand. Any update across platform integration for users with different tenant IDs? I will get back to this. I am not sure as of now on the tenant IDs. I'll get back to you, Mr. Rahul, with the email. Is there any free trial to know the software well? There is no a trial version on the platform from the Dassault system as of now. However, if you are interested to check the capabilities of it, you are always welcome to our premises 1 or 2 days, and we will be having the demo licenses, and you can basically test your ideas. I'm also interested to learn from scratch. Okay, our training covers all these things. I hope I know I'm very happy to see so many questions, and I'm remain thankful to all of you being attentive in this whole webinar. So keep watching our webinars going forward. We'll be having a lot of webinars concentrating with respect to design, with respect to governance, with respect to simulation, manufacturability, and so on. Keep watching the webinars to get more information. So with that, we are closing this webinar, and thank you once. Thank you all. Please provide us the positive feedback, which we will redirect it once we close this webinar. Thank you very much again. Thank you.